Okay, so the first problem we've got here is about a ball on the top of a hill, and what's going to happen as it rolls. So as the ball rolls down the hill, that gravitational potential energy at the top of the hill is going to get transferred into kinetic energy. When it reaches the bottom of the hill, it's going to have its maximum amount of kinetic energy, which is going to have been transferred from whatever the maximum amount of gravitational potential energy was at the top. Now, in reality, some of that energy, as we've said, is going to get dissipated to the surroundings due to friction as thermal energy. But for these problems, it tells you not to take account of that, because we're talking about the maximum. So the maximum kinetic energy at the bottom is always going to be equal to whatever the gravitational potential energy was at the top. So first thing we've got to do in this is work out the gravitational potential energy at the top of the hill. So that's using our equation. Gravitational potential energy is mass times gravity times height. So m times g times h. So mass of this is 2 kilograms times gravity, 9.8 newtons per kilogram, times the height. Now we look on the diagram, that's 2 meters. So we just plug that into our calculator. So 2 times 9.8 times 2, and we get a value of 39.2 joules. So that is what the gravitational potential energy was at the top of the hill. Now, to work out its maximum kinetic energy at the bottom of the hill, it's just that. So at this point here, what's going to be its kinetic energy? Its kinetic energy at the bottom of the hill maximum is equal to the gravitational potential energy at the top. So you've already worked that out. That is just 39.2 joules. Now, what they will do on the higher level paper and higher level questions is, so foundation, you'll be expected to be able to work out gravitational potential energy and do that side of things. And you'd be expected to understand that that is going to be equal to the maximum at the bottom. Now, high level, you need to be able to take that figure now and use it to calculate what the maximum velocity would be at the bottom of the hill. So if I just rub this out a second, so we can go through that. So our kinetic energy equation is half times mass times velocity squared. So we write the equation out, then we plug the values in. Always do it this way because you get marked for just substituting this in. So I know that that's 39.2 is equal to 0.5 times the mass, which was 2 kilograms, times the velocity squared. Now I get a mark just for writing that out. Now I need to rearrange it. If it's times on this side of the equation, it becomes divide on this side of the equation. So 39.2 divided by 0.5, use my brackets, times 2. When you're putting it into your calculator, it's important you do that. Now that's going to give you v squared. Now it's up to you. You could square root this all at once in your calculator and do it that way. So I could press the square root button on my calculator, then press the fraction button on there, put 39.2 in the top, go down, bracket 0.5 times 2, there's my bracket, press equals, and it's just going to work it out for me straight away. If I do that, I get a value. So if I did it like that, wrote it into my calculator like that, I get 6.26 meters per second, or 6.3 meters per second. So I can do all that on my calculator. If I wanted to, I could work that out, just work this bit out, and then square root the answer. It doesn't matter which way I do it. But that's the method of doing it. So just remember, work out the gravitational potential energy at the top of the hill. Know that that is going to be equal to the maximum kinetic energy at the bottom. Then put that value into the kinetic energy equation, and you'll have everything apart from velocity. Rearrange it, to find velocity. Remember, because it's velocity squared in the equation, you must square root it, like we said when we were doing those equations before. Okay, hopefully this helps you understand it.